fantasy football.
I was busy writing about, I already forgot his name, like Alfredo Linguini or something stupid.
Linguini? Alfred with an A? It's a
Yeah, Linguini.
So anyway, okay. Periodic table. Periodic table, there is a lot of work that has happened to get us to this periodic table that we have. So whenever the first elements we was discovering them and chemistry was getting it started, a long time ago, there was a guy that has been labeled as the father of the periodic table. His name, you might know it?
You said it.
Oh, God. Let me think.
Alfred Nobel.
No.
That's Walt Disney.
Mr. Periodic Table.
Alfredo Linguini.
Dimitri
Mendel.
White.
Mendel.
Mandelos.
Mario.
Melendez.
Jesse.
Mussolini.
Medici.
Walter White.
It's Dmitri Mendeleev.
Mendeleev.
Dmitri Mendeleev is labeled as the father of the periodic table because he was doing something one day. So back in the time when Dmitri was there and he was coming up with the periodic table, there's a whole bunch of scientists that came up with the periodic table. It was like, well, this one's mine and this one should work and this one. So Dmitri Mendeleev came up with his periodic table. And he found it very interesting that at the time they'd go back and forth. Some would label them through atomic number, some would label them based off of their average atomic masses. And it was just quite confusing. So he was looking and he was like, you know, if we do this with the average atomic number, there's trends on the periodic table. These guys these elements, they'll act the same. But they're kind of the same things. They have trends to it. So like the perfect example, my favorite column on the periodic table, which is probably most of the guys in the room's favorite column, is column 1.
Is that the explosives?
Because column 1, proving my point, thank you, John. Column 1 is the alkali metals. The alkali metals are very, very fun.
Boom, boom.
So you first start off with lithium. Helium, you just like ignite it and it burns, and then yeah, it's great. Lithium.
I love me a
You take lithium, you throw it in water, and it like fizzes around. You're like, oh, that's cool. You take you some sodium, you throw it in there, you're like, that thing like really fizzes and rolls around, and you know, if you put enough in there, it releases some hydrogen and the heat, and it ignites, and there's fire and fizzing, and water is like, woo, yeah! Then you get in there and it's like potassium. You put that in there and it's like really fizzing around. Next thing you know, it ignites and there's an explosion. Like, yeah!
Can we do that?
No!
Why?
So next thing you know, you get rubidium. And rubidium you throw in there and it's like, yeah! And that thing just like erupts and then there's an explosion.
It makes a screaming man.
Yeah, exactly. Yeah.
Get in there.
Next thing you know, you get cesium. You take a hold of some cesium. Now, cesium's a really interesting one. You put that in there, squirt some water, to boom! That's all it does. It just goes boom! Explodes.
Can we do that one?
So, no.
Can we do any of that?
I don't even know if they would let me have cesium.
I can get you some. I know a guy.
I'm good, John. I'm good, John. I'm good, Trey. I'm good. So,
That means me after school.
he looked and said that there were trends to this, but there's other people that have done this. The reason Dmitri Mendeleev has been labeled as the father of...
Con.
No. Father of the periodic table. Just because of what he did that was so special. He left blanks. I know, right? How many times have you left a blank on something and a teacher got on to you? And now I'm telling you that this guy's a genius. Here's the reason why. His blanks were fillers. He put a blank there. And he said, we don't know this thing yet, but it exists. And you know what? I'm going to tell you about it.
He's right.
And he told you about the properties. He told you all sorts of details about the element. He'd tell you about the melting point. He'd tell you about boiling points. He'd tell you about reactivity. He would tell you any special properties.
But he didn't know what it was.
Well,
Not yet.
not yet, because he hadn't had it.
He was dead.
So, interesting thing takes place. So if you look on your periodic table, atomic number 13, we find a element. which is,
Aluminum.
look at you, see? I told you, you'll at least get a B.
I'll find you an L.
Aluminium.
Right here.
Aluminium.
I'll find you an L. Bengals. Take it.
British.
Oh. What happened? What happened to your team?
So here's aluminum. You look at aluminum, you go down from aluminum.
Good try.
You have gallium. This is what Mendeleev did. He left a blank.
You have
You know what he called it? Eco-aluminum, which meant one below aluminum. Germanium, he predicted the existence of germanium. He predicted the existence of them, so this is a really cool thing. Is there's this French scientist in France that discovers gallium. So he discovers it. The French dude holds it in his hand, and Mendeleev is like, whoa, bro. Actually, I discovered that, not you. Like, I know more about it. So the French dude's like, here it is, I got it, I know more about it. Here's the really cool thing. Mendeleev could tell you more about the element without ever touching it, seeing it, or holding it, based off of his periodic table, than the French dude that actually held it and is the one that is credited with discovering it. His properties, everything he predicted for that element was more accurate compared to present day standards than the guy that actually held it in his hand. This is why Mendeleev is called the father of the periodic table.
And he has an L.
Now, you go 50 years and you do not have any reasoning or explanation behind why periodic law, which is what that has been called, with the special properties, chemical, physical properties of these elements, until Mr. Henry Moseley comes on the board in 1911, and he comes in and he gives the explanation and explains it.
So two things came out of 1911 that were really cool.
We reached that point that I'm trying to think what I can do. Okay, so I spoke with you guys about the ideas with the history of the periodic table and stuff. I really don't like to talk about it. When we left off at the point I was getting ready to start talking about trends. So whenever I do trends, I really do not like talking a lot about them, but unfortunately they are useful to us in chemistry. So I like to hit 3 of them. If I remember correctly, there's 8 or 9 different trends. And this guy just don't like going through all those trends. It's pretty brutal. But there are certain trends we'd like to talk about. So today we speak on the trends of the periodic table. Very nice. Now, the first trend we're going to talk about, I want to make sure I give you the same thing that I gave first period the other day, so we're going to start using my pictures, make sure I get everything right. We're going to talk atomic radius. So, atomic radius is the distance. Wow, that's a big S.
There's a big S.
I erased it and made it small.
I want to see a big one. Yeah! Man, nobody's laughing today. Everybody's tired. Y'all got your inhibitory.
You know why?
Maybe you just lost your spark, John.
Okay.
That's funny.
Anybody know that commercial?
Yes.
No, I know.
Geico
Hey,
commercial?
Greg, guess what day it is? What day is it? It's home day! I know that commercial.
Get it because it's camel saying
You remember Puppy Monkey Baby?
Yeah,
Oh, get it away.
I hated it, man.
I want to kick it.
What?
I don't want to buy the drink just because this is an awful commercial.
What?
Alright, anyway, so the distance between the middle
Puppy Monkey Baby.
nuclei of the same element.
Chemistry notes.
No, that's what he's wearing. He says khakis.
So that's what I'm saying. Like we got an atom here, you got an atom here. There's two atoms, they're the same element.
What's their last name?
It looks like circles to me.
Y'all just got
Adam Sheffer, Adam Sandler.
So the middle, you take the middle and you get the distance between them, and that is your atomic radius.
It's a circle.
I just.
It's two circles, John.
Well, but look, it goes down. Atomic radius is the distance, and that's the same thing. It goes back up.
You know. Thank you.
If we were to have a
Stop. There are trends based off the periodic table, and it works out for us very nicely.
So we have to go back to the beginning?
Sorry, I got an update about the college football playoffs expanding.
Did you know West Virginia is in like NCAA bracket for we're supposed to be? We're supposed to be in something. And if we're talking like program history, like I think it's like
volleyball.
Richard Tech, like something.
Let's
Volleyball.
go Navy.
Alright, so the trend for atomic radius is as we go down the periodic table. As you go down the periodic table, the atomic radius will increase. Now, the reason you see this thing increasing is because as you go down the periodic table, you keep increasing the number of electrons, hence we have to increase the number of energy levels. So we keep adding energy levels.
Oh, so they're farther apart. Because the outer ones are together.
If you need to move closer, you can.
Yeah, Maddie.
Thanks.
Sorry, John, go ahead.
So they're farther apart because the outer energy level is together on the electrons, so the atoms, so the atom's nucleus is farther apart. Makes sense. I don't know if I explained it right, but it makes sense. Anyways, how you guys doing today?
It's kind of like whenever, you get you a pizza, and you got you a medium pizza.
Why can't it be?
And then it's like, you move on down the menu, and you got a large pizza.
Honestly, if you literally go back and watch every single one of those videos, there's 20 minutes of teaching, and then there's 30 of John and Andrew.
Let's go!
And then,
Killing your YouTube thing. Small
and then you go down again and get an extra large pizza. And what are these pizzas keep doing? They keep getting bigger. Wow, they keep expanding. And the same thing with the atom, you keep adding energy levels so they keep getting bigger. Now, not only is there one for when you go down the periodic table, but across the periodic table. When we talk about across the periodic table, when we talk left to right, like you're reading. As you do this, it will decrease. Very nice. The reason we have the decrease in the atomic radius is because you're not.
Listen, we didn't have beans today. I don't know what y'all are doing. That's another 10% on the video.
I think it's a drill.
It is. They're drilling into
So
the
the decrease comes because you're no longer increasing energy levels, but you're increasing protons. So as we increase the number of protons, this has a greater positive attraction. More positive charges in there means stronger attraction towards the nucleus. So the electrons are more attractive.
I would assume that's, yeah, that's right. Left to right.
See?
Like you're reading.
Yeah.
Okay.
Okay.
Now what happens if we come at it horizontally?
That, we did, that's horizontal, that's the cross.
Well, horizontal would be a combination of two.
That's diagonally.
Wait, oh,
We're trying to learn.
Oh, you did something.
You know what I'm gonna hear tomorrow? Hey, did you put those grades in yet? Nope. Okay.
That's right. Merry Christmas.
Next one we're gonna talk about is a pretty cool trend. I don't like talking about the trend, but the whole idea behind it is kind of cool. So ionization energy.
So this is not, this is different than active radiation.
Yeah. Ionization energy. Ionization energy is just a measurement for the amount of energy or the amount of energy required to remove the valence electron. Now, if you guys ain't heard of what valence electrons are, don't worry about it. Mr. Hawk, yeah, he can teach you. Valence electrons is what y'all said.
Yeah.
These are the outermost really?
I didn't know. I thought I said that quiet enough you wouldn't hear
You think I'm old?
it.
you're slowly climbing the ladder. We all are. The unstoppable marching of time stops for no one.
Electron is the outermost electrons, or?
It means they are the
Okay,
outermost
Grandpa,
electrons.
yeah, we'll come see you later. I'm talking to you.
Start talking about the unstoppable marching one time and I can look at it
All
differently.
your grandkids.
Yeah, it's okay.
Huh? I'm talking to him. I wasn't calling you Grandpa. You don't even have any regular old kids yet. You ain't got no, you ain't upgraded to grandkids.
Great.
I'm like 4 or 5 years out from a grade to kids. You talking?
It's a skill tree. You gotta unlock normal kids, and then you get down to grandkids.
Can I help you?
Kids?
You dug a hole and you're digging.
You're still digging.
I'm making a joke. It's like a skill tree.
A skill set?
All right, so you go down the periodic table, it will decrease.
In a video game? Anyways.
So as we go down the periodic table, it decreases, and the reason it decreases is greater distance between the valence electrons and the protons.
Is that protons? Yeah.
Yes. Now, as you go across the periodic table, you get differences, okay? So you got some changes. The thing that changes is the reasons as to why. So we'll go across the periodic table. we focus in on the columns. So when we do this, you kind of leave the transition metals, which is D block, alone because they're freaky. But we'll look at columns 1, 2, and 13. Columns 1, 2, and 13, the ionization energy will increase. Reason? You're adding more electrons. So then you break it down.
So,
Is this saying 13 over or 13 and the reasoning for that is?
1, 2, 13, the reason.
Okay.
Is that better if I do 2 columns?
Yeah. Because I thought it was like 13 over. That's what I
Go to columns 15.
Wait, so columns 1, 2, and 13. there's no-
Brody Klein, Rebecca Morgan, and Ashton Reed. Report to the office, please.
15, 16, and 17. You get an increase. Reason you get an increase, you get more electrons, which means it's easier to gain electrons to reach octet. Octet.
is that E?
I know y'all didn't forget octet now.
The octet rule, you know,
All those first.
everybody wants to be like no gas.
Since they have 8.
They got 8, so everybody wants 8 valence electrons. Octet rule, that's what you're looking at. That's why we're going to the bonds. This will transition us and bring us into the bonds.
Cool.
See?
Yeah. And octopus. Octopi. I said octopus.
Gone.
Octet. Thing.
Okay.
Oh, that's one of those, like, things you play music in. Octet. That's a cool octet.
That wasn't even, that,
Is that a quartet?
You sound confused. That wasn't even funny.
he doesn't even know what's going on.
All right, the last one is the one that we do not. This is why I still teach this.
Okay, great.
Because of how valuable this trend is and how important it is in terms of bond. Electronegativity. Electronegativity is this number attached to an element for the pull it has on another atom's electrons. So staying with our trend, get it? We're talking about trends, we're making trends. Yeah. Down the periodic table. As you look at it, you go down the periodic table, you're going to decrease. We'll have this decrease. The reason there's this decrease is the atom energy levels since we're adding the energy levels, greater distance from the protons in that atom so the bigger atom you have, the farther those protons are from the other atom's electrons.
Is any of this supposed to make sense right now? Because it don't.
That no, it will.
None of it does.
Awesome. That's the joy of chemistry. You start off confused, you learn it, you master it, and you impress everybody. Then you destroy the SAT.
Dude, I won't even consult with it.
All right, you go across the periodic table. It increases.
Don't put me in home.
It increases because as you go left to right on the periodic table, you are increasing the number of protons. Sorry. So you're adding more protons, which is the positively charged subatomic particle, which means it increases the attraction. Attraction. So, Mr. Ha have great news. Tomorrow, you come in here. Hot news for you. We are done with trends. We're done talking about periodic table. Ladies and gentlemen, we are going to get into the fun stuff.
Aww.
We're going to start getting into the fun stuff. This is the real chemistry stuff, okay? So this is where chemistry is going to start getting into that stuff that you all, whenever you think of chemistry, you think of this. This is the foundation for what is to come. So we are going to start talking about bonds.
That's not what I think of when I think of chemistry.
Chemical bonds. Thank you.
Wow. No, it's I'd be distraught if someone didn't understand that.
When you start pulling my hair out.
Dr. Cook knew it. I mean, that's saying something.
That is
All right, so within chemical bonds,
whether you believe it or not.
we're going to start going through these and talk about the different types. Now, we're getting close to that nasty little devil
Nomenclature?
nomenclature.
Yeah, I know.
This is the foundation of nomenclature. I haven't put one note on the board. This is your foundation for nomenclature. You have to know what the substances, what bonds are in the substances, and those are going to tell you how to name them.
Okay.
So before I get anywhere in this, understand, this is the foundational piece to this. If you don't get bonds, you're in trouble for nomenclature. If you don't get nomenclature, you're in trouble for chemical reactions. If you don't get chemical reactions, you are in trouble for stoichiometry.
So we need bonds?
So, by the associative property, if you don't get bonds, you're not going to be able to get stoichiometry.
I don't think that's the associative property. That's the transitive property.
Domino effect.
My brain just went down.
Greg went down, now he's searching it up.
He's looking. I do a lot of balance. I don't for fun.
John, go check your graph.
The transitive property.
I'm sorry, transient property.
If egg was big and B
Ron,
was
I'm playing
C.
chess on your computer with my toes.
I apologize. Transitive property. There you go. Thanks, John, for the correction. Anyway, you have to get bonds for you to be able to get this. If you're going to be successful for the rest of your chemistry time, if that's just with me or if you're going off to college to do something with chemistry, you have to get it now. This is key. Okay? So, there's really 3 types of bonds, but one of them breaks into 2 different categories. So I'm going to introduce you into the 4 types of bonds we will discuss in this class. The first one, the one we will start on in today, is ionic bonds. Ionic bonds are something very familiar to you without you knowing about them. Good examples of these is table salt.
Sodium chloride.
Sodium chloride. That, it goes by different names, different brand names, like super melt, driveway melt. The stuff that looks like the little tiny round white balls, that's calcium chloride. Also, an ionic bond. Number 2, I'm going to break these 2 up. We will discuss them together, sort of, but we're going to break them up right now. The first one is a nonpolar covalent bond. Going along with this is number 3, a polar covalent bond. Everybody in this room, please do me a favor and tell me you have heard of non-polar covalent and polar covalent. Yes?
Yes.
You said that before.
Oh my God.
I remember.
You've said those words before.
I remember you saying something about polar bonds or something in like biology. With the little fringy looking things.
I have no idea.
Yeah, I don't know
That's all
what's
I
talking.
remember.
No, wait, what else?
Alright, it's okay. It's okay. It's okay. We will go over it. Okay? It's not hard. It's not complicated. I was just curious of how many people do it. Apparently, I will slow my pace just a little bit. And number 4 is the fun one. I bring in the 4th one because it's one of those things that you get to learn about that answers questions you have just in general in life. Number 4 are metallic bonds.
Can you spell metallic now? Let's go on. I just read that title like that before we created. I know what the fuck I did.
Thanks, grammar bullies.
You're welcome.
Always good to know I got a grammar Nazi in the room. And a math Nazi.
That's me. You know, you got a brown crap again.
Associative property is when you put parentheses. Like if you do 2 plus 4 plus 5, you can do 2 plus 4 or 4 plus 5.
What do you want to do with your life?
Teach math.
You come back here. You should come back here.
Yeah,
I think you should. It'd be a lot of fun. You know, you teach here, you be on that side of the hall, I'd be on this side. It'd be like a war. Science is the way. It'd be like math is the way.
I like science.
Yeah.
You dress up.
I don't know.
I've
I've
been
been
looking
thinking
at
about,
science
I've been
today.
thinking about going into engineering. I don't know. I'm taking physics though. And
I hope we have. a
I have
physics
no
class
reason
next
to go
year.
to.
I got a feeling I will, because this your class likes to be challenged. I'm just being honest. I'm sorry. I mean, no shots
Thanks.
fired. But the truth of it is, I love the seniors. But the fact of it is how many people signed up for physics?
I didn't sign up for physics for the reason that I thought you had to have chemistry before you have
No, I
physics.
was literally. I had it on
So,
my mind.
it's
You know
okay.
how upset I was?
But
They made me change.
also, look in this room. How many seniors are taking chemistry?
2.
I think a good amount.
There's a few.
There's a
I
few
know
that's
there's
taken
way
last
more than
year.
2.
Are there more in here?
One.
There's more
You're a
to the last
senior?
year. Yeah.
I didn't even know you were. I didn't know SEL were seniors.
You didn't know I was a senior?
I know you were a senior.
More
I didn't think you were.
juniors are jumping into these classes. And On one thing you can't debate against, I'll watch in the room, and I'll watch when I'm teaching stuff. I've seen kids, I've seen the juniors light up. They want challenged. Now, I'm not saying that's not true for the seniors. You absolutely do. You're a senior. You're in this room. You knew exactly what you were signing up for.
Yeah.
You want a challenge. I'm saying overall class-wise. So look at your classmates.
I didn't even know there was
Okay? But I think we will. I think it'll come back. Now, I'm going to be honest with you. I think it'll be small class again.
I'll be here next year. I just about guarantee it.
No,
So
you're a
long-
senior, John.
So long as I have.
Another thing is also is look at the AP Calculus class. How many is in AP Calc?
Literally.
You wouldn't.
Yeah, no, I'm not
You
taking
wouldn't
that.
take
I'm not
it.
taking that.
Now, next year, it'll be a different story because their class has a lot more.
There's 30 kids
Then
in my
our
trade
class
class.
ended, like-
Only 3 of them are seniors.
There's
Yeah,
not-
but that's the
there's never
thing
been
is
great
you'll
kids
We
in
have
our
see.
like 2
class.
seniors in ours.
You all will see, and this is nothing against, I love the seniors, and y'all in this room, you absolutely want to be challenged. And the truth of it is, you took a challenge, you accepted it, you're mounting up to it, and you're doing great. Compared to the rest of them that ran off. Now, the funny thing's going to be, you go to college, have to deal with chemistry, and you'll be like, yeah, whatever, man. Yeah, I'm ready for this. And they're going to be freaking out, be like, I'm totally lost. How do you understand any of this? And you'll be like,
Mr. Hall.
did you not take Hall's class? I mean, it kind of explained it. So, I'm happy you're here. No shots fired at you. I'm throwing fire at the other kids that are not signed up for chemistry.
I get to go.
I'm worried because if I go back to Powell, I have to go to East for the rest of the school year. Or until I get my license. Because I can live with my brother, so I know my brother's not going to drive me to West Side. That bus goes to Powell. So I'm worried that I'd go to East and have, I don't know how to get a chemistry. I don't know if it teaches them. But
We're different. She teaches different. I do different.
senior year, I should have my license. I'm coming here because my girlfriend's going to homeschool, so I have no reason to go to East. So, but if I take AP chemistry and if I was taught over there, the rest of the stuff, I'm worried I'm not going to need to know.
You'll still be in.
Okay, yeah.
I ain't gonna kick you. Alright, anyway, sorry for the delay, sorry for the interruption, blah, blah, blah. Anyway, so you gotta ask yourself on this, one big question when you're looking at bonds. As to why bonds form. Whenever we get to these two, we'll talk a lot more about it, but just a brief little intro for now. When you're looking at chemical bonds forming, the bonds form for one major reason. Form to lower the potential energy. Everything's looking to have as little energy as it can and to just be stable. That's what it's really looking for, stability. So another reason you'll see these bonds forming are based out of stability. Like, typically my guys in the room like this, girls, if you're into it, cool, but guys, when you look at it, things like C4, and I'm not talking the pre-workout. I'm talking, I'm putting this on the door, sending an electrical charge through it, and it's going to make the door go bye-bye. Yeah!
Yeah.
What do? It's a compound that's mixed up and it has nitrogens that are sitting close to each other but they're bonded to other things. The most stable bond on our planet is nitrogen.
I remember you told us that.
Yes, nitrogen bonded to nitrogen. So what happens is nitrogen's sitting there and it's like dying to be with nitrogen. And it's staring at it. And it's like, I just can't, but these bonds are holding me back. And then whenever they send the electrical charge, it breaks the bonds, and they can form together. And the difference in the amount of energy gets transferred, because the law of conservation of energy, gets shoved right into the door and say bye-bye. So, this is what you're looking at. It's all there to form off and to lower the potential energy. Now, I want to go ahead and get started in. I don't know how fast we're going to get through bonds. Hopefully we can get through it pretty quickly so we can keep up pace. But I want to talk to you about Ionic Bond. And what these guys really are. So ionic bonds are bonds formed from atoms gaining and losing electrons this forms ions that are opposite charged which is attracted. Oh wow. Start off fancy. Which is attracted to each other. I'm gonna give you a golden rule, and the older I get, the more I just live by this rule. I will go ahead and tell you, you can use, remember that trend we talked about, electronegativity, and how on your periodic table there's electronegativity values attached to every one of those elements for those atoms. With that, you can use the differences between those to determine what type of bonds you're going to form. I gotta be honest with you, there's a second way, and anymore, I just like the second way. It's kind of the golden rule. It's very simplistic, very easy, very quick.
Do one to others as you come to yourself.
What?
What's the golden rule?
Don't pee on the toilet seat. That's another one. That's the golden rule. I didn't even mean to do
What
that.
you do to one side, do to the other.
Also, is should be R.
Ionic Bond.
Them electrons tracked is
Because it's plural. Anyways,
Oh, okay, I
Ionic
see what he's
bonds.
talking about now, I didn't understand what
which
the word he was
is
talking about.
attracted.
Hey,
yeah,
John,
yeah.
this one's for you.
Oh no. Oh, I don't care.
You hesitated to write C. You do care.
There should be an apostrophe on don't.
Yeah.
Oh no.
Checkmate.
You should make that a question mark too. That'd be extra.
I don't care.
Okay.
I don't know.
When you're looking at ionic bonds, these form between a metal and a non-metal.
On the periodic table, aren't there non-metals and metals?
Metals is a nice metal.
Look at you!
I remember seeing.
So you guys know about the metals and the
So
non-metals.
wouldn't it just be in the middle?
Not really.
You guys know how to tell the difference between a metal and a non-metal.
Don't
Everybody
have to do
knows.
something with their
We just should
numbers?
see the periodic table.
Wait, hold on. Isn't everything on that side like non-metal?
It's so simplistic.
I've just colored in a periodic table before.
It's so simplistic. Have you ever looked at Mr. Hall's periodic table
No.
and wondered what this red line is all about?
Non-metals, metals.
The red line is the staircase to success for you identifying your bonds.
Yeah.
Tobacco.
Okay.
With this,
Very steep staircase.
Yeah.
it's the line that separates the metals and the non-metals. To the left of the staircase, We have metals.
Oh, I see this in fourth period because you didn't answer.
Then non.
And the right side,
Can you put an exclamation mark?
we have non-metals.
That ain't lead gas.
What?
Is it non-metals?
Non-metals?
I don't really know.
All right.
What's in the S?
On the left side is metals. Hence, column 1, alkali metals.
Gold.
Column 2, alkali earth metals. Columns 3 through 12, the transition metals.
17.
How come?
What about the F block?
What about H? What about hydrogen?
Yeah.
I didn't know. I thought that was a gas.
Hydrogen is a non-metal. Breaks the rule.
Okay.
Red.
Basically, if there's ever a rule, hydrogen and helium don't apply to it because they're special.
Yeah.
They're weird. It depends on the rule that you got. It's kind of like, you know, you get in advanced math classes and they're like, hey, here's this rule, but this rule only applies in this case. And then there's this rule, but this rule applies in this case. And you go back to that first case and this rule applied and in this case and in that case.
And different properties apply, like the transitive property.
Exactly.
Just like that.
So the metals are to the left, except for hydrogen. To the right are the non-metals. It's that simple. Now, I'm going to look at you and go ahead and tell you something. For the purpose of this class, and for those of you that are in here, sorry to my seniors, but to the juniors, that you have the guts, and you love the challenge, and you love spending 45 minutes a day with Mr. Hall this year. And you say 45 minutes a day is not enough in physics. I need some AP chemistry.
I can't wait for another 90 minutes. I can't take both. Sorry.
If you take AP chemistry, I'm still going off this rule. I'm not going to deal with that difference in electronegativity. And there's also this other piece of information. I'm giving it to you in case you get to college and you have some dinosaur or a professor that just ain't letting the old ideas go and he acts like it's so important. There is a third option. They're called metalloids.
I've heard of that.
All your metalloids are some of those that's right on the staircase, so to the left or right. Am I looking at you and telling you that they're all metalloids? No, I'm just telling you that they are. In our case, in our class, we're not going to worry about distinguishing the differences in them. Okay? It's not that important. I'm just letting you know that so that whenever you get to college and you've got that dinosaur of a professor, bada boom, bada bing, you're good. Okay? Any questions? So, Ionic bonds. How they form. Kind of a review of what I just said. But I want to use an example to go with this. So when you're looking at ionic bonds, you will take, that's a better way of saying it. I got to fix that first. I like this way better. You will see the metal atom will, it's typically, this is what it will do. In this class, we're going to say this is what it does. Whenever you're in your advanced inorganic chemistry class in college, when your professor tells you that this is what happens for this one, just go with what he says, okay? This is the foundation for chemistry, not the advanced class. You will see the metal atom will lose / give an electron / electrons. The nonmetal will receive. The electron or electrons. This is kind of the golden rule you're going to see taking place with this. A good example of this. Take sodium, for example. So you all know the electron configuration of sodium, right? 1s2, 2s2, 2p6, 3s1. Thank you.
How'd you just bring your papers?
Not her, somebody else. She had brought me papers from somebody else. I guess this is the class. It's the revolving door for sophomore credit rescue.
It's good as end of the day, and they have to do it now.
Here's the thing I want you to look at and I want you to notice. So we all focus in on valence electrons, and that's what we're going to talk about here. Whenever you're giving, losing, gaining, you're talking valence electrons. We're all about valence electrons. Your bonds are all included and involved in valence electrons. What electrons do we deal with when we're talking to bonds?
The valence ones.
Valence electrons. How many valence electrons, which is the outer energy shell, does sodium have?
I do not understand either.
One.
What is going on?
Okay,
You know.
I can find out.
let me do this and let's see if it helps.
Okay.
Less than.
Sodium has one valence electron. The way I know sodium has one valence electron, I know it because of a rule I'm going to teach you later on. I'll probably hit tomorrow, but it's going to be, the columns off the periodic table will tell you. First column has one valence electron. Here's the way you know. What is the highest energy level sodium has an electron in? 1, 2, 3. 3. The third energy level. So you have sodium sitting over here with its one valence electron. And sodium's just looking for the date to the prom.
Oh, that's so sweet.
Waiting to give her sweet electron to the greatest date.
Also, that was a really nice circle. Yeah.
Thanks, man. Chlorine.
What's the cup? That's fine.
Let's look at chlorine. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. How many valence electrons does chlorine have? 7. This is why. What's the outer energy level?
3.
3.
You have an S and a P. There's 2 electrons in the S, 5 in the P.
You add them.
You add them, it gives you 7.
4.
In the little circle. 7 valence.
So, we do a circle. Let's get a chlorine. We'll put our 7 electrons. 1, 2, 3, 4, 5, 6, 7. And I bet every one of y'all did what people in the first period did, and you just evenly distributed the 7 and you forgot your electron field order.
2, 2, 2, 1.
Oh.
We have to go 1, 1,
Okay.
1, 1.
Chlorine has 7.
Isn't that
When you deal with octet, no. When you deal with the octet, you're looking for 8 electrons. That's what every atom is looking for.
Is 8?
Is 8.
octave?
So, sodium wants 8, chlorine wants 8. They're lazy. Elements and atoms are lazy.
You're going to mush them together and make sodium chloride, aren't you?
So what's easier to get to 8? For sodium. Look at sodium here. In the second energy level, how many valence electrons does sodium have?
8.
Has 8. Second energy level, second energy
Gabriel
level.
Creelman, Kyla Reed, and Ariana Woods, the office.
2 in the S, 2 in the P. That gives you 8. But that's not my valence electron. I still got the 1 there.
You said 2 in the S, 2 in the P.
Oh, I'm sorry. That's 6 in the P. Sorry. 2 in the S, 6 in the P. If I can get rid of that 1 electron, will I have a full octet? Will I have a full outer shell?
Yeah.
That's what sodium will do. Sodium just gives up the electron.
None of this makes sense. I mean, it kind of does, but it kind of don't.
Whenever that happens, you get sodium with positive charge. Why? Number of protons didn't change. Number of electrons changed. Number of negative charges is what's changed. Now sodium has a full octet because it's coming from the second energy level.
So would that make it 2 all the way around?
So now sodium has a full octet. Chlorine picked up. Let's do it this way. Sodium. Looking for the love of his life. We changing the story.
We're inclusive. We don't discriminate.
Changing the story. Because of how, well, like the laughing and the facial expressions I got. And I was like, I didn't mean what they thought I meant.
It very much sounded like that.
Yeah, and that's why we're changing the story, John. John's face really said it. So let's say, for example, sodium, looking for the love of his life. Finds chlorine, the love of his life. He gets the ring. Gives her the ring. God, I mean, he loved her, put the ring on her. Now, sodium got the full octet, and chlorine, she gets her ring, she gets to plan her wedding, she's so happy, she's so excited, except for the day before, because when we rides up, I'm just kidding. So chlorine added an extra negative charge. So now it's negatively charged. But they both...
Okay. What's it
Multiply.
negative?
It multiplies.
I'm so confused. I will see
Chlorine's
you tomorrow
neutral.
at lunch. 'Cause I
That's right. Chlorine's neutral. But it picked up an electron. So before, it had the same number of protons and the same number of electrons.
So as soon as you added that other one, it makes
I added an electron, added a negative charge.
Because an
Chlorine's
electron
now
is negative
negative.
charge.
Sodium lost one.
Okay.
So now, what happens here? This is positive charge, this is negative charge. What's the opposites do? They're together forever. And holy matrimony.
Until we break their bond down
Opposites
until
attract.
we send the
Because That electron's gone. It came down here
Trauma pulls them apart.
and added.
And the child soft dies.
Listen, I get it. It's a little confusing. Don't worry. I'll see you Monday when we go back over this.
I'll see you tomorrow.
I'll see you tomorrow.
Why are we going over it tomorrow?
Because tomorrow's a break. I've learned this in chemistry. Yeah, I'll give you a break. Even if you don't have lab, if I can't get my hands on the chemicals I need to locally to do the lab, I'm still giving you a mental break because chemistry is so hard you need a mental break. Which is why I do it that way. Friday quiz, Friday lab, Friday quiz, Friday lab. And most of our labs are going to lead into Monday. So you end off on a good note and you start.
Need any tannerite?